Betelgeuse has been acting weird for years now, and scientists just figured out why there is actually another star hiding right next to it that nobody could see until recently. This ghost star has been messing with Betelgeuse this whole time, making it look like the red giant was about to explode when really something completely different was going on. The discovery changes everything we thought we knew about this famous star, and the story of how researchers found this hidden companion is absolutely wild. Let me take you back to late 2019, when astronomers first noticed something strange. Betelgeuse started getting dimmer and dimmer, which was really unusual because this star is normally one of the brightest objects in our night sky. You can see it with your own eyes, up there in the shoulder of the Orion constellation, and suddenly it was fading away. People got worried. Scientists got excited. Everyone started wondering if we were about to witness something that humans had never seen before in recorded history. The thing is, Betelgeuse is what we call a red supergiant, which means it is absolutely massive compared to our sun. If you put Betelgeuse where our sun is right now, the star would stretch out past the orbit of Jupiter. It would swallow up Mercury, Venus, Earth, and Mars completely. The star is so big that even though it is about 650 light-years away from us, we can actually see it as a tiny disk through powerful telescopes instead of just a point of light like most other stars. That is how enormous this thing really is. Now, when a star gets this big and this old, it means it is near the end of its life. Betelgeuse has already burned through most of its fuel, and one day, probably sometime in the next 100,000 years, it is going to explode in what scientists call a supernova. This explosion will be so bright that even though the star is 650 light-years away, you will be able to see it during the daytime here on Earth. It might even be as bright as the full moon for a few weeks. Then it will slowly fade away, and Betelgeuse will be gone forever, leaving behind either a neutron star or a black hole. So when the star started dimming in 2019, a lot of people thought, maybe this is it. Maybe we are about to see the supernova. Social media went crazy with posts about how Betelgeuse was going to explode. News articles started coming out warning people that the star might go supernova any day. Some folks even got scared thinking the explosion might hurt us here on Earth, even though scientists kept saying we are way too far away for that to happen. But here is where things get interesting. The dimming kept getting worse through December and January, until by February 2020, Betelgeuse had lost more than half its normal brightness. For a star that usually sits as the 10th brightest star in our sky, this was huge. Then, just as mysteriously as it started, the dimming stopped. The star started getting brighter again, and by April, it was pretty much back to normal. No supernova. No explosion. Just a really weird dimming event that left everyone scratching their heads. Scientists started coming up with theories to explain what happened. The most popular idea was that Betelgeuse had burped out a huge cloud of dust that blocked our view of the star for a while. Red supergiants are known to do this sometimes. They have these massive convection cells on their surface where hot gas rises up and cool gas sinks down, kind of like a lava lamp, but on a scale that is hard to even imagine. Sometimes these convection cells can throw off huge amounts of material that forms dust clouds in space. Researchers used computer models and observations from different telescopes to support this dust cloud theory. They found evidence that Betelgeuse had indeed ejected a bunch of material from its southern hemisphere, and this stuff had cooled down enough to form dust particles that blocked the light. Case closed, right? Well, not exactly, because that dimming event was just the beginning of the weird behavior. After Betelgeuse returned to its normal brightness, astronomers kept watching it closely. They noticed the star was pulsating in a strange way. Betelgeuse normally pulses, with a rhythm of about 400 days, getting a little brighter and dimmer in a regular cycle. This is totally normal for red supergiant stars. But after the great dimming event, this rhythm got all messed up. The star started pulsing faster, with a period of only about 200 days. It was like someone had sped up the heartbeat of this giant star. This is when some scientists started to wonder if maybe there was more to the story. A star does not just change its pulsation period for no reason. Something had to be causing this change, and the dust cloud theory did not really explain it. Sure, a dust cloud could block the light temporarily, but why would it change how the star itself was behaving? Some researchers started looking at old observations of Betelgeuse going back decades. They found something really interesting. The star had actually dimmed before back in the 1980s, though not quite as dramatically as in 2019. And when they looked at the long-term brightness data, they saw patterns that did not quite match what you would expect from a single star just doing its own thing. Then, in early 2024, a team of astronomers decided to take a really close look at Betelgeuse using some of the most powerful telescopes we have. They used interferometry, which is a fancy technique where you combine the light from multiple telescopes to get super detailed images. It is like making one giant telescope out of several smaller ones. With this technique, they could see details on the surface of Betelgeuse and even look at the space right around it. What they found was absolutely shocking. There, hiding in the glare of Betelgeuse, was another star, a companion star that had been there the whole time, but was too faint and too close to Betelgeuse for anyone to spot it before. This ghost star, as some people started calling it, was orbiting around Betelgeuse, pulling on it with its gravity and affecting everything about how the red giant behaved. The discovery explained so much. When two stars orbit each other, they pull on each other with gravity, right? This pulling can cause all sorts of interesting effects. It can make stars pulse in weird ways. It can pull material off one star onto the other. It can create bright spots and dark spots on the surface. And most importantly for our story, it can cause dimming events. Here is what scientists think happened. The companion star, which is probably a smaller main sequence star, kind of like our Sun, has an elliptical orbit around Betelgeuse. This means instead of going in a perfect circle, it follows more of an oval path. Sometimes it gets closer to Betelgeuse, and sometimes it swings farther away. When the companion gets really close to Betelgeuse, the gravity between the two stars gets stronger. This extra gravity tugs on the outer layers of Betelgeuse, pulling material off the surface of the red giant. Remember, Betelgeuse is so big and so bloated that its outer layers are not very tightly held on. The gravity at the surface is actually pretty weak compared to a smaller, denser star. So when the companion star swoops in close, it can literally pull streams of gas off of Betelgeuse. This gas gets stretched out between the two stars, forming what astronomers call a gas bridge or a stellar stream. Some of this material might fall onto the companion star, while other parts of it get flung out into space. And here is the key part. When this gas cools down, away from the heat of Betelgeuse, it can form dust particles. lots and lots of dust particles. So the great dimming event of 2019 and 2020 probably happened because the companion star had recently passed close to Betelgeuse, pulling off a huge amount of material that formed into a dust cloud right in our line of sight. The dust blocked the light from Betelgeuse, making it look like the star was fading away. Then as the companion star continued in its orbit and the dust cloud dispersed, the star brightened up again. This also explains why the pulsation period changed. When you have two stars orbiting each other, their gravity affects how each star vibrates and pulses. It is kind of like how the moon affects the tides on Earth, but way more extreme. The companion star tugging on Betelgeuse was literally changing the rhythm of how the red giant pulsed, making it beat faster than it normally would. But the story gets even better, because once scientists knew to look for the companion star, they started finding evidence for it everywhere. They went back through old data and found tiny wobbles in Betelgeuse that matched what you would expect if another star was pulling on it. They found variations in brightness that lined up with the orbit of the companion. They even found hints of the companion in old photographs, though it was so faint compared to Betelgeuse that nobody had noticed it before. The researchers calculated that the companion star probably takes about 2,000 to 2,500 days to complete one orbit around Betelgeuse. That is roughly 6 to 7 years. The orbit is pretty stretched out, with the companion getting as close as maybe 1.3 times the distance from Earth to the Sun at its nearest point, and swinging out to maybe 5 or 6 times that distance at its farthest point. These are rough estimates, because scientists are still working out the exact details, but you get the idea. Now you might be wondering what this companion star is actually like. Scientists think it is probably what we call a B-type main sequence star. This means it is hotter and brighter than our Sun, but not anywhere near as big as Betelgeuse. If you could see this star by itself, without Betelgeuse blinding you, it would probably look bluish-white and might be about 5 to 10 times more massive than our Sun. Not small by any means, but compared to Betelgeuse, which is maybe 15 to 20 times the mass of our Sun, and hundreds of times wider, it is like comparing a marble to a beach ball. The really interesting question is, how did these two stars end up together? Stars in binary systems usually form together from the same cloud of gas and dust. But Betelgeuse and its companion seem like an odd couple. Betelgeuse is old and dying, while the companion is still in the prime of its life, happily fusing hydrogen into helium in its core, like our Sun does. The answer probably has to do with how stars evolve at different rates depending on their mass. See, the more massive a star is, the faster it burns through its fuel. Betelgeuse started out as an even more massive star than it is now, probably something like 20 or 25 solar masses. It burned through its hydrogen fuel really quickly and puffed up into a red supergiant. The companion star was less massive to begin with, so it is taking longer to use up its fuel. It is still chugging along as a normal star, while Betelgeuse has already reached old age. This kind of situation is actually pretty common in binary star systems. You often find one star that has evolved into a giant or supergiant paired with a smaller star that is still on what astronomers call the main sequence. Sometimes the giant star can even transfer material onto its companion, which can cause all sorts of interesting effects. In fact, scientists think this might be happening with Betelgeuse and its ghost star, though probably not a huge amount, since the stars are still pretty far apart for most of their orbit. The discovery of this companion star is important for a bunch of reasons. First, it means we can finally explain all the weird behavior Betelgeuse has been showing without having to come up with complicated theories about what the star is doing all by itself. Second, it gives us a chance to study how stars interact with each other in a binary system, especially when one of them is a red supergiant near the end of its life. We do not get many opportunities to observe this kind of thing up close. Third, and maybe most importantly, it means Betelgeuse probably is not going to explode as soon as we thought. See, one of the reasons scientists thought the star might be getting close to going supernova was because it was acting so weird. But now we know a lot of that weird behavior is because of the companion star, not because Betelgeuse itself is unstable. The red giant is probably more stable than we thought, which means it might last for tens of thousands of years more before it finally goes boom. Of course, this does not mean Betelgeuse will never go supernova. It absolutely will one day. Red supergiants like this always end their lives in massive explosions. But the timeline might be longer than people were thinking when the star started dimming in 2019. Instead of happening next week or next year or even next century, the explosion might not happen for 50,000 or 100,000 years. That is still incredibly soon on astronomical timescales. But for us humans, it means we probably will not see it in our lifetimes. The companion star might actually affect when and how Betelgeuse explodes too. Some theoretical models suggest that having a companion can change how a supergiant evolves by pulling material off of it or by adding extra material to it. This could make the star explode sooner or later than it would on its own. Scientists are still working out the details, but it is a fascinating area of research. One thing that really captures the imagination about this discovery is how long the companion star stayed hidden. Betelgeuse is one of the most studied stars in the sky. Astronomers have been watching it for hundreds of years. Professional telescopes have been observing it constantly for decades. And yet this whole time, there was another star right there that nobody could see. It was like a ghost, haunting Betelgeuse, hiding in plain sight. The reason it took so long to find the companion is partly because Betelgeuse is so incredibly bright. When you have a star that luminous, it is really hard to see anything near it. It is like trying to spot a candle next to a searchlight. The glare from Betelgeuse drowns out the light from the companion. Only with modern techniques like interferometry could astronomers finally tease out the faint signal of the companion star from the overwhelming brightness of the red giant. Another reason the companion was hard to find is that it is pretty far away from Betelgeuse compared to the size of the red giant. If you were standing on a planet orbiting one of these stars, the other star might look like just a very bright star in the sky, not like two suns close together. The separation between them is wide enough that they are not constantly touching or transferring huge amounts of material back and forth. They are just close enough that their gravity affects each other significantly. The discovery has also made scientists wonder about other stars. How many other famous stars might have hidden companions that we have not found yet? Binary stars are actually super common in the universe. More than half of all stars are in binary or multiple star systems, so it would not be surprising if other bright stars we see in the night sky turned out to have companions we have not detected yet. Some researchers are already going back and taking another look at other supergiant stars to see if they might have companions too. Stars like Antares, and Aldebaran, which are also red giants, might have secret partners affecting their behavior. Who knows what we might find when we look closely enough? The techniques used to discover Betelgeuse's companion are getting better all the time, too. New telescopes and new methods for analyzing light are making it possible to see things that were invisible just a few years ago. In the next decade, we will probably discover a lot more hidden companions around other stars. Each discovery will teach us more about how stars form, evolve, and interact with each other. For Betelgeuse, specifically, scientists are now planning a whole bunch of new observations to learn more about the companion star and the system as a whole. They want to measure the exact orbit of the companion. They want to figure out the precise mass of both stars. They want to understand how much material is flowing from Betelgeuse to the companion and vice versa. They want to study the dust clouds that form between the stars. All of this will help paint a complete picture of this fascinating system. One of the cool things about studying Betelgeuse and its companion is that we can actually see changes happening in real time, or at least on timescales of years instead of millions of years. With most astronomical objects, change happens so slowly that humans could watch for entire lifetimes without seeing anything different. But Betelgeuse pulses and brightens and dims on timescales we can actually observe. The companion star completes an orbit every 6 or 7 years, which means we can watch it go around and see how it affects Betelgeuse during different parts of its orbit. In fact, scientists are predicting that we might see another dimming event sometime in the next few years, based on when the companion star should swing close to Betelgeuse again. If that happens, and we see the star dim on schedule, it will be strong evidence that the companion star theory is correct. Astronomers will be watching closely to see if the prediction comes true. The discovery has also sparked interest from amateur astronomers who like to monitor Betelgeuse brightness. With just a decent telescope or even binoculars, you can see Betelgeuse and estimate how bright it is compared to other stars in the area. During the 2019 dimming event, amateur astronomers around the world contributed valuable observations that helped scientists understand what was happening. Now that we know about the companion, people are excited to keep watching and see what happens next. There is something almost poetic about a hidden star affecting one of the most visible and famous stars in our sky. Betelgeuse has been a beacon in the winter sky for as long as humans have looked up. Ancient cultures saw it as part of Orion the Hunter. They told stories about it. They used it to navigate. And the whole time, there was this secret companion star silently orbiting around it, affecting its brightness and behavior in ways nobody understood. The story of the discovery is also a good reminder that science is always evolving. What we think we know today might change tomorrow when someone makes a new observation or comes up with a new theory. Back in 2019 and 2020, the dust cloud theory seemed like a pretty good explanation for the dimming. Most scientists accepted it. But then as more data came in and people looked more carefully, they found evidence for something more complex. The companion star theory fits the data better and explains more of what we see. This is how science is supposed to work. You make observations. You come up with a theory to explain them. Then you keep testing and refining the theory as you get new information. Sometimes you have to throw out the old theory completely and start over. Sometimes you just need to add to it, like what happened here. The dust cloud idea was not completely wrong, but it was incomplete. Adding the companion star to the picture makes everything make more sense. The researchers who discovered the companion star used data from multiple telescopes and combined it in clever ways. They used optical telescopes to measure the brightness and color of Betelgeuse. They used infrared telescopes to see through the dust and look at what was happening close to the star. They used radio telescopes to detect molecules in the material around Betelgeuse. And they used interferometry to get super sharp images. By putting all these pieces together, they could see the complete picture, including the hidden companion. This kind of multi-wavelength astronomy is becoming more and more important. Different types of light can tell us different things about what we are looking at. Visible light shows us one thing. Infrared shows us another. Radio waves show us something else. By combining all these views, we can understand objects in space much better than if we just looked at them one way. The discovery also highlights how important it is to keep watching the sky even when we think we already understand what we are seeing. Betelgeuse has been observed for so long that it would have been easy for astronomers to assume they knew everything important about it. But by keeping an open mind and being willing to look for new explanations, when something unusual happened, they were able to find something that had been hidden for all these years. Now that we know about the companion, star scientists can use this information to understand Betelgeuse better and make better predictions about its future. For instance, they can now account for the companion gravity when they model how Betelgeuse might evolve over time. This will give more accurate estimates of when the star might go supernova and what the explosion might look like. The companion star might even affect the supernova itself. Some theoretical work suggests that if a red supergiant has a companion, the companion can shape the explosion and affect how the debris expands into space. The companion might create an asymmetry in the supernova, making it brighter in some directions than others. This is all very speculative right now, but it is something scientists are thinking about. Another interesting question is what will happen to the companion star when Betelgeuse does eventually explode. The companion will be hit by a massive blast of energy and debris traveling at incredible speeds. It might get a lot of new material added to it. Its orbit will definitely change because Betelgeuse will lose a lot of mass in the explosion, and that will weaken the gravity holding the two stars together. The companion might even get kicked out of the system entirely, flying off into space on its own, or the companion might survive and end up orbiting whatever is left behind after the supernova. Betelgeuse will probably leave behind a neutron star, which is an incredibly dense object about the size of a city, but with more mass than the Sun. The companion and the neutron star would make for a very interesting binary system that astronomers would love to study. But all of that is far in the future. For now, the focus is on understanding the system as it exists today. Scientists want to know everything they can about how these two stars interact. They want to measure how much material flows between them. They want to understand how the companion orbit affects the pulsations of Betelgeuse. They want to figure out what causes the dust clouds and how often they form. Each new observation adds another piece to the puzzle. Recent measurements have helped narrow down the size and temperature of the companion star. Other observations have tracked how the brightness of Betelgeuse changes as the companion moves around its orbit. Some researchers have even started to see hints of how the companion affects the shape of Betelgeuse pulling one side of the red giant slightly toward it. The discovery has also renewed interest in trying to take a picture of the surface of Betelgeuse. We have managed to get images before, but they are pretty fuzzy. With the new knowledge about the companion star and better telescope technology, astronomers hope to get clearer pictures that might even show the bright spots and dark spots on the surface that are caused by the companion gravity. Imagine being able to see the surface of a star hundreds of light years away in enough detail to make out features on it. That is the kind of amazing thing modern astronomy can do. We live in a time when we can not only discover hidden companion stars, but actually see the effects they have on their giant neighbors. The story of Betelgeuse and its ghost star is still being written. Every few months, new research papers come out with more observations and more analysis. Each one adds to our understanding of this remarkable system. What started as a mystery about why a star was dimming has turned into a whole new understanding of one of the most famous objects in the night sky. And through it all, Betelgeuse keeps shining up there in the shoulder of Orion. On a clear winter night, you can walk outside, look up and see it easily. That reddish-orange star is Betelgeuse, still pulsing, still changing, with its invisible companion silently orbiting around it. The star looks the same to our eyes as it did to our ancestors thousands of years ago. But now, we understand so much more about what is really going on. The discovery reminds us that the universe is full of hidden wonders waiting to be found. What we see on the surface is often just part of the story. There are layers of complexity and mystery beneath the obvious facts. A star that we thought we knew well turned out to have a secret that changed our entire understanding of it. This is what makes astronomy so exciting. We are constantly discovering new things, learning new facts, and updating our understanding of the cosmos. The universe keeps surprising us no matter how much we think we know. And every surprise, like the discovery of Betelgeuse companion star, opens up new questions and new areas to explore. Scientists are already thinking about what other discoveries might be waiting out there. If Betelgeuse had a hidden companion, what about other stars? What about stars that are even farther away or harder to study? As our technology gets better, we will be able to look more closely at more stars, and we will probably find a lot more surprises. The techniques developed to find Betelgeuse companion can be used to search for other hidden stars. The data analysis methods can be applied to other observations. The theoretical models that explain how the companion affects Betelgeuse can be adapted to understand other binary systems. Each discovery builds on the last one, helping us understand the universe a little bit better each time. For the people who made this discovery, it must have been an incredible moment when they first realized what they were seeing. Imagine spending months or years carefully analyzing data, looking for any clue about why Betelgeuse was acting strange. Then one day, you see it right there, in the data, a signal that can only mean one thing. There is another star. All the pieces suddenly fall into place, and everything makes sense. That is the joy of scientific discovery. It is not just about adding to human knowledge, though. That is important. It is also about the thrill of understanding something for the first time, of seeing something nobody has ever seen before, of solving a mystery that has been puzzling people for years. The scientists who found Betelgeuse companion got to experience that, and now they get to share it with the world. The news of the discovery spread quickly through the astronomy community and beyond. Science websites wrote articles about it. Planetariums updated their shows to include the new information. Teachers started telling their students about the ghost star haunting Betelgeuse. The discovery captured people's imaginations in a way that not all astronomy news does. Part of the appeal is that Betelgeuse is such a famous star. People know it, even if they do not know much about astronomy. It is bright, it is colorful, and it is easy to find in the night sky. So when scientists announced they had found something new about it, people paid attention. It was not some distant galaxy or some object that only experts had heard of. It was good old Betelgeuse with a secret. The story also has that element of mystery that people love. A hidden companion star is like something out of science fiction. The idea that something could be hiding right there next to one of the brightest stars in the sky, and we could not see it, feels almost magical. It reminds us that even in our modern age, with all our advanced technology, there are still things right in front of us that we have not discovered yet. And there is something comforting about the explanation too. When Betelgeuse started dimming, people worried it might explode. The idea of a supernova is exciting, but also a little scary, even though scientists kept saying, "We are perfectly safe." Now we know the dimming was probably just caused by the companion star and dust clouds. Betelgeuse is not about to explode anytime soon. It is just doing a complicated dance with its partner, and sometimes that dance creates effects we can see from Earth. The discovery has also led to some interesting discussions about how we talk about astronomy with the public. When the dimming first happened, a lot of media coverage focused on the possibility of a supernova. Headlines talked about Betelgeuse exploding, which was technically possible, but not very likely. This created some confusion and even some unnecessary worry among people who did not understand the full context. Scientists have learned from this that they need to be careful about how they communicate uncertainty and probability. Just because something is possible does not mean it is likely to happen soon. And when talking to the public, they need to make sure people understand the difference. The companion star discovery actually helps with this, because now there is a clear explanation for the dimming that does not involve an imminent explosion. Looking forward, there is so much more to learn about Betelgeuse and its companion. Scientists want to know if the companion has any planets orbiting it, though that seems unlikely given how close it is to Betelgeuse and how chaotic the environment is. They want to know if there might be any other companions in the system, maybe smaller stars or even large planets that we have not detected yet. They also want to use Betelgeuse as a laboratory to study how stars interact in binary systems. Because we can observe changes happening on human timescales, we can test our theories and see if they match what actually happens. This is rare in astronomy, where most things change so slowly that we can only study them through computer models and statistical analysis of many different objects. The discovery might also help us understand other mysterious behaviors in other stars. If Betelgeuse, strange dimming, was caused by a companion, maybe other stars that dim or brighten unexpectedly also have hidden companions. Scientists can now look for similar patterns in other stars and see if the same explanation works. One of the beautiful things about this story is how it shows that science is a process, not a destination. We did not just suddenly understand everything about Betelgeuse. We observed something strange. We came up with an initial explanation. We kept looking, and found evidence for a better explanation. And we are still learning more every day. That is how science works at its best, constantly questioning, constantly refining, constantly seeking better understanding. The companion star is also a reminder that individual objects in space often have complex histories and relationships. We sometimes think of stars as isolated points of light, but many of them are part of families. They have companions. They affect each other. They change each other. The universe is not a collection of separate objects, but a web of interactions and relationships. Betelgeuse and its companion have been dancing together for millions of years. They formed together from the same cloud of gas. They grew up together, even though Betelgeuse grew faster and reached old age first. They have been affecting each other all along, pulling on each other with gravity, exchanging material, creating the complicated behaviors we see today. And they will stay together until Betelgeuse finally explodes, and maybe even after that. It is a story of partnership and interaction on a cosmic scale. Two stars bound together by gravity, going through the stages of stellar evolution together. One is old and dying, while the other is still young and healthy, but they are still connected, still affecting each other, still part of the same system. For anyone who loves astronomy, this discovery is a gift. It gives us a new way to think about Betelgeuse and a new appreciation for how complex the universe can be. It reminds us that there are always more discoveries to be made, more mysteries to solve, more wonders to find. The universe is not running out of surprises anytime soon. And every time you look up at Betelgeuse now, you can think about that companion star up there, orbiting around the red giant. You cannot see it with your eyes, but it is there, doing its invisible work, affecting everything about how Betelgeuse behaves. It has been there all along, a ghost haunting one of the most famous stars in the sky, waiting patiently for someone to discover it. The researchers who made this discovery deserve a lot of credit for their careful work and their persistence. Finding a faint star next to a bright one is incredibly difficult. It required advanced technology, yes, but it also required careful planning, clever analysis, and the willingness to look closely at something that many people thought was already understood. They had to believe that there might be more to the story than what everyone else was seeing. That is an important lesson for anyone interested in science. Do not just accept the first explanation that seems to work. Keep looking. Keep questioning. Keep testing. Sometimes, the most interesting discoveries come from taking another look at something familiar and finding something new that was hiding there all along. The companion star was always there, circling Betelgeuse, affecting its brightness, causing it to pulse in strange ways, creating dust clouds. But it took the right tools and the right approach to finally see it. Now that we know it exists, we can understand so much more about why Betelgeuse behaves the way it does. This understanding will continue to grow as scientists make more observations and do more analysis. Each orbit of the companion star gives us new data to study. Each pulsation of Betelgeuse tells us something about how the gravity of the companion affects it. Every dust cloud that forms gives us clues about the material flowing between the stars. The more we watch, the more we learn. And through all of this, Betelgeuse remains one of the most magnificent objects in our night sky. It is a star in the final stages of its life, burning brightly before its inevitable explosion. It is a laboratory for studying stellar evolution and binary star interactions. It is a mystery that we are slowly unraveling, and it is a beautiful sight that anyone can enjoy on a clear winter evening. The ghost star haunting Betelgeuse has revealed itself at last. What seemed like preparation for a supernova was actually the work of a hidden companion all along. The dimming that worried so many people was just dust clouds created by the interaction between two stars locked in an eternal dance. Betelgeuse is not dying quite yet. It is just living out its complicated life with its partner by its side. So what do you think about this whole ghost star situation? Is it kind of crazy that something so big was hiding right there next to one of the brightest stars we can see, and nobody spotted it until now? Do you think there might be other hidden companions around famous stars that we just have not found yet? Drop your thoughts down in the comments because I really want to know what you think about all this. And hey, if you enjoyed learning about Betelgeuse and its secret partner, do me a huge favor and smash that like button right now, because it really helps the channel grow and lets me know you want more space stories like this one. Also, you should definitely check out the video popping up on your screen right now about why the whole universe spins, because that is another mind-blowing topic that connects to what we just talked about in some really interesting ways. The universe is full of these amazing mysteries, and we are just getting started exploring them together. So click on that video and keep the journey going. Thanks so much for watching, and I will see you in the next one.